Here we need exactly four variables on a minimum scale in order to solve any question from relative motion. Now that you know this, you'll also realize that the only thing you need to find is the rest to the question will only ask the other two variables, or it will ask any of the other left variable out of the six. Four known values, and you'll have two or only one of the rest to find out. So let's check a small example here I have taken in 1 minute. So, okay, so in this question, a car, a car A is moving with speed 7 meter per second in north direction. Another car B is moving with speed 37 degrees north of west. What is the velocity of car B and velocity of car A with respect to B? So I like to, okay, I just wanna confirm, is my cursor visible? Can somebody reply in the chat? Okay. So, okay, thank you. So, in this, if you see this table, it is a very nice way to just see all you have. Because see, all you have is six variables, and you know, and all of them are in the question. So, and in this question particularly, they're asking the rest of the two of the variables. So, what you do is you jot down all the things, all the known values, and what you do not know is the magnitude of the b vector and c vector, right? So, this is, and after that is simple math. If you, I mean, doesn't it all sound simple after this, right? So this understanding or problem analysis, or so I would like to call it, can solve any problem in relative motion, and I think this understanding is a powerful tool when you are solving any question from this per se. Any questions on this part? Any doubts? Okay. I'll continue then. So next part is graphs. So there are three types of graphs that we come around, and GEE loves graphs, and it asks, excuse me, it asks graphs questions of almost 16 to 20 marks in every exam. So if any, excuse me, very sorry about that. My voice just cracked. I guess it is still cracking, but I'll move on. So next part comes on graphs. So JE loves graphs questions, and any serious JE aspirant, I guess, should not lose any marks in graphs. And when someone has a good grip on graphs, they should be able to translate a graph given, and should be able to visualize the whatever the kinematics are happening, or whatever the path of motion is, and should be able to convert a given situation into a graph. So let's encounter this. Let's see how this is going to happen. I have made it short and sweet here. So there are three types of graphs we have, that is XT, VT, and AT graph. So each have slope and area, slope and area. So if we think about the XT graph, the slope gives instantaneous velocity, right? And depending on the question, the result of the area varies, but that is depending on question, so that is something you should look out for on your own. And next comes VT graph. So the slope of VT graph gives instantaneous acceleration, and the area gives displacement. And when it comes to AT graph, the slope gives jerk, that is the rate of change of acceleration, and the area gives you the change in velocity, that is v final minus v initial. So let's check a few examples here. So in this second example, we have uh, a graph given where the particle starts its motion from point x naught and goes up and comes down to and the velocity becomes zero at time t equal t2. Okay, so when we have to convert this or visualize this in form of motion of the particle, we realize that at since the slope at this point is at the point t1 is 0, and the velocity is 0, and it takes, since the velocity is 0, we can understand that the motion of particle takes, or the particle takes a turn at t equal t1, right? And it becomes 0 at t equal to t2. So does this make sense, or anything, any questions about this? Okay, so next, let's see another good example. I like this graph a lot. It starts from velocity v1. It's a vt graph. It starts with initial velocity v naught, and the slope again becomes 0, where it takes a stop. Okay, so that's what you see here in the motion. And then the velocity increases first, and then it decreases, and it becomes 0 at t2, which means it is taking a it is taking a turn, because velocity is 0. It is taking a turn at this point, and then it is again going on in negative t, right? And now let's check how to convert a situation into a graph. All right, so now we have a basic projectile motion here, and here the ball is starting from origin, and when it is thrown up with velocity 20 meter per second, what is the yt and vt graph? So Martian, yeah, these questions are from my personal notes and different sources I have collected. This session PDF will be shared later if you want. Moving on. This is again, you can find out these values by simple kinematic equations. So in a YT graph, what happens is it's a parabolic motion, it's a ballistic motion. So at time 2 seconds, the projectile becomes, it reaches its highest point, that is 20 meter per second, which is again found by simple kinematic equations. And then the time of flight is 4 seconds, and this can be depicted this way in this graph. Does this make sense to you guys? Does this make sense? Okay, sure. So I'll repeat it. So what happens is, in a basic, this is a projectile motion, right? So once you throw a ball up in the air with velocity, initial velocity 20 meter per second, from origin, what happens is, at a time t equal to 2 seconds, it reaches its highest point, that is 20 meters. And you can find this by simple kinematic equations. And the total up and down motion takes, or the which is also called the time of flight, takes 4 seconds to happen, right? So this time of flight is 4 seconds, and we know that at a distance equal to 20 meter, and time t equal to 2 seconds, which is the max height point, um, your the position of the projectile is at its highest point. So since this is a projectile motion or a ballistic motion, it is a parabola, and this is how you depict it in a YT graph. Is it clear now, Blaze? Okay. Now, when I see a velocity time graph, it goes with initial velocity 20 meter per second, that is already known. And at time t equal to 2 seconds, it becomes 0 because at highest point velocity is 0, right? So, and then it comes so the ball is again falling down. I hope, please try to visualize this properly while I speak. So imagine the event happening in front of you. The ball is going 20 meter per second, and it's at its highest point. The velocity is 0, and the time at which it reaches its maximum height is 2 seconds, right? So while coming down again, it comes with a velocity of minus 20 meter per second, and that's how you find your VT graph. And the acceleration time graph is a constant graph, and I guess that's the most easiest part of all of these graphs, and you can do that as an exercise if you wish to. A personal suggestion from my side is Play with the Graph by Arihant. It's a very good book to um, try out more graphs. And as I said, the value of graphs in at least in physics in all of JE is 16 to 20 marks, which is a lot in my opinion. So please do not take this lightly, and any serious JE aspirant should be able to solve any graph question. Okay, any questions now? Okay, so moving on to the next part is friction, and the question might not be very clear here, and I leave it to you to do a little bit more exercise on this. But here the situation goes as a block of mass 2 kg and 5 Newton force is applied on this block. This is a highly debated question by among many teachers in physics. This is a JE question, and when it came, there was a lot of debate on this question because it was not clear whether tension comes first or friction comes first here, because we need to start off with something in order to solve the question, right? So this is a highly debated question, and yes, hmm, uh, the block is connected by a string. So the block is connected by a string, and it has tension. Okay, so in order for tension to come on and show its effect on the block, friction should take place first. Please remember this, right? So since friction is there, friction should come first, and then comes tension. So this is if you ever encounter this kind of question, please take friction first, and then comes the tension, right? Is that clear? Okay. And I use this relation you can see on screen, quite sometimes in my exams to check my answer. Wait, someone asking me a question. What's the argument of people who see tension constant? I am not really sure of the complete picture, but this is I actually um, heard this from my teacher. He was involved in this debate. So he asked us to not involve in these debates and focus on physics. Okay, okay. I'll move on. When this relation you see on screen, this is a very interesting relation, easily derivable on your own. If you can try this after the session is over, and if you need some help, please ask in the server itself. Either I or others who are there will try to help you derive this on your own. But this is an interesting and nice relation you can remember. And I have saved my marks in exams by using this relation quite sometimes, because I make quite some silly mistakes in my exams, and this was a good method for me to check if my answer was correct. So the force lies in this particular range that you see here, and if your answer is coming out of the range, obviously it is wrong. So I guess that's that about this relation. I'm not going into detail, because detail would just be deriving this relation, which is not the point of this session. Next comes projectile motion. This, one minute. Okay. The thing you see on the screen right now, this is all you have to know in order to answer any question from ballistic motion or projectile motion. So, again, easily derivable on your own. Always feel free to ask questions in the server if you need some help with derivation. I really encourage derivations, since these not only help you understand the what's happening in this, but it also gives you a feel of the subject, and also helps you in remembering these formulas. There are quite a lot of formulas, and if you derive these results 2 or 3 times on your own, you'll someday just remember it too well. Okay. So the I'll start from this. So initial velocity, initial velocity. The x component is u cos theta, right? So u cos theta is always constant. Um, U cos theta, unless, okay, I made this mistake once. The x component of initial velocity is always constant, unless you have an external force such as air drag or something else coming in between. So the x component is only constant as long as there is no external force in the x direction. So if you find air drag in the question, please do not make the mistake of taking the x component also as constant, because, well, it is not constant. Okay. So the y component is u sin theta, and that varies along the projectile, and the rate at which it decreases is minus gt. So that's why at a particular point of the ballistic motion, you see that the y component of the velocity goes as u sin theta minus gt. Okay. Now if I let's see. Uh, okay, got this. Okay, got this. So if I am just taking this particular triangle, so and I take this as x and this as y, so my displacement here will be x square plus y square. That is the displacement, and that's again just from simply Pythagoras theorem. Nothing much to explain here again, right? And the coordinates of this at any point will go as x coordinate will be ux t, and y will be uy t minus half gt square. Again, these are easily derivable from simple kinematic equations, right? And the speed, and these are just some other relations you might want to check out. And any questions so far? Any part you want me to elaborate on or anything? So the real feel of omega, or anything, comes in this understanding the value of omega in a non-circular path. So this is very exciting. So what happens is, let's say I have O is observer and P is particle, let's say. And what happens is, if I imagine this as a um, circular motion. My with omega, I can using circular motion concept here. I can simply solve this question and or any question related to this format. So what happens is, let's okay, this is a question that I have put for follow up. After this explanation, you might really want to check this out. I know Calda, Jan Carla's questions are not exactly JE perspective, but this is a very good exercise. I would encourage you to go ahead and do. So what happens is, the observer sees the particle with angle theta, right? So let's, okay, I want you to imagine this happening, okay? You are watching someone running, you are at rest, okay? And you are watching someone move, and you have to turn your head to look at that person, yes? So so that is what happens here. So that is theta, that tilt of head is theta. And the velocity of the particle has both, its components go as v sin theta and v cos theta, right? Please let me know if you're not able to follow. This is not easy to follow. So if you are not able to understand, let me know. Okay. So there are two components that you can get out of this velocity, v parallel and v perpendicular. So v perpendicular is responsible. So now if you look at this in a circular motion point of view, you can understand that the v perpendicular is responsible for the change in velocity of the particle. Yes or no? Right? So since v perpendicular is responsible for the change in motion here, um, the omega will be equal to the component of v perpendicular to r, right? Component of v perpendicular to r divided by the distance between O and P.
Unless I'm unmute तब तक नहीं आते हैं.
So the distance between O and P is nothing but the radius itself of the circular part. I want you to imagine this in both, like this is non-circular part, of course, when you see it simply, but please make an effort to actually add on a circular path intuition here. And do you guys have any doubts? Please work this problem out. Problem 34. This uses this. So you can start off this, just draw the diagram first for this question and use this relation that you see here. And yeah, any doubts? I see no response here. Is am I audible? Okay. Okay, cool. Okay. Next part is of center of mass.
So, like the center of mass formula is x m1 x1 plus m2 x2 by m1 plus m2. In this relation, what you understand is that actually, if you say that distance having using this, you'll realize that they're inversely proportional to each other. So like d1 by d2 is equal to m2 by m1. I've solved many questions, like almost 15 questions, which could have taken me more than 5 steps to solve a particular question. You can try deriving this result on your own and solve questions relating distance and mass. So like this is a very interesting relation that I have derived on my own, and you can too. So any doubts? uh, oh, okay, so this is a two questions are just ideas, just thought it would be nice, and interesting to look at these problems. Let's say we are having a particle with velocity 50 meter per second. It hits the wall and falls back on ground at whatever this point is. And if the question is asked, then we can use the projectile motion we have discussed above and solve for any question here. And like if you observe this properly, you can see that this diagram to form, like it forms a projectile, like it goes from the ground, hits the wall and goes back, and if you open this up, it is just a simple projectile, right? So that's about this question. Like it's a simple idea, right? So you can keep this in mind for other question. So the last question says that, like this is a situation where two particles are falling on the ground at the same point of time and same place. We know that the time taken by both the particles, like the overall, is same. Like this idea can simplify many of your problems, and again this is, you can simply use other projectile motion equations further. So this is all for this session. So thank you all for your attending. Thank you very much.